First, thank you for the invitation. First time for me in Tallinn, even if our office participated some years ago, I think it was in 2007, in a competition, also in Tallinn, but the project unfortunately didn't went on, so I'm here now for more theoretical issues. Today I want to show you a few projects, and I want to split the presentation into two parts. First, a little bit about our approach to architecture and to projects and what we do see in this great issue of sustainability, which is a word which is far too big to describe it with only one word. And we show a little bit about the complexity as we understand it and how we try to solve it. And in the second part, I will show you our 22-26 building, which is one, let's say, major conclusion we drew out of the past 30 years as we worked on this issue of sustainability. The first part is called 200-150-2010 and is related to the different aspects in sustainability and what we see in architecture, what affects most this description of sustainability, and how can we master it. To start, no images. You can be sure you will get enough images, too much probably, but to explain a little bit better our thinking, I will show you some images too. To start here, a little bit about our approach. The first is, and if we talk about settlements, we are not only talking about cities. We are also talking about other settlements, that means housing projects which come together. And what we show here is how we can reach this goal to increase the social and cultural value of the settlements in the most efficient way. And we think this is one of the very important things. We should not focus, and also not focus in this conference, only on the issue of energy and of reduction of CO2. We think this is one very important issue, but we have to be very aware of the situation that we are within a more complex and holistic world, and we need to look at certain things at the same time. So just to highlight a few of them, individual well-being is something which is very important in the society nowadays, because individuality is such a high value, and also consumption and everything, which is also to be seen as a very critical issue. But we have to face it, and we have to see that the individual well-being, and that means the thermal comfort, visual and acoustic comfort, is one of the things that's a standard. But also we have to face the fact that social relationships and economic security are very important factors which will influence this goal very much. And what I will not tell how you can solve it, we only say these are different points which should be taken in consideration when developing new projects. Another one is social developments, which is, and you see how vast this field is. Migration is a big thing. Ways how we communicate today, the aging of society, all these things are influencing very much this goal, how we can create sustainable developments and sustainable projects. Resource efficiency, and that's what we are talking, or what we should talk today about. Resource efficiency is one issue, but you can see the thing is much bigger than that. And we think it's very important not to focus only on this issue, and this issue here means materials, tools to calculate, reuse of recycling materials and things like that. We think, and energy use for sure, but I will come back to that later. But resource efficiency is only one small part of much others. Open buildings, I will also come to these 3 points: densifying, resource efficiency and open buildings. I will mention them later. You will see images about it and projects where I can describe a little bit what we mean when we're talking about this. Open buildings, it's about floor heights, structural grid and things like that. How we can make our buildings work not only for the function where they are designed for now, but they are also able to bear different functions in the future, because if we only design the buildings which was done in the 50s, 60s, 70s as a result of the functionalistic and modern classic architecture, it turns out now that we have big problems with these buildings, and we should really be interested in to make buildings which are able to bear the functions much longer than only these decades as we face it right now. Densifying is a very important issue for the future, how we can optimize the use of square meters per person, and how we can work with the resource building land. Because very often the people don't think that this is also an issue which is extremely important nowadays, because all the cities are growing, but we don't consider that there are other possibilities to organize ourselves within existing city developments or village developments. And there are other things like local tradition, social and cultural acceptance. These are things which are extremely important and which have influence on this goal to achieve long-lasting settlements. Environment, maintenance costs, which is influenced through climate, topography, history, conventions, and things like that. It seems, or it sounds probably a little bit of abstract, but in the end, if you don't consider these things right from the beginning, you will fail with the development. The next step then, if we say we have all these bigger look, a bigger view about the settlements, the next thing is to look on efficient buildings, long-lasting efficient buildings, and then we say, what is then the goal? And here it's to keep the social and cultural value of the building in the most efficient way. And that is what I explained before with the 200, 150, and etc. years, that we should look that the building works for more than 100 years. And at the moment, this is not at all really the form driving or the force driving issue when we look in investments, in developments, but that should be the goal. And for that, we need at first to look at the local background with all his sub-themes, as you can see them here. We have to look at comfort, which is once more the issue of the personal well-being. We have to look about flexibility. We have to consider the structural grid, floor heights, possibility of different uses, neutrality of the facade, and we need also to face escape strategies and the spatial organization of service of opportunities. So these are things, the flexibility is one of the very important things we have learned from history, because very old buildings and the ones which remain in the cities until now, they proved that they were able to do so. Because when we face it in our countries, in the German-speaking countries, a lot of the buildings which were used to be built in the, let's say, 19th century and beginning 20th century, they are still valuable and you can use them. Whereas in the following areas of functionalism, these buildings provide a lot of problems to us nowadays. And we have to learn from these things. The next is contribution to the site, which is also extremely important, because we don't believe that, as it's done very often, that the project is only focused on its success itself and not considering that with doing a project you need to bring a value, a benefit to the environment. And if you don't do that, you will fail also with the project. You need this contribution to the site, and that means architecture is not only design of objects or of material and of volumes, it's much more. It's designing of relations. That's the very important thing. Another thing is about efficient buildings, the construction method, which needs that we have to think not only which materials we use and how we do it, but what is the knowledge we have on place. What can we do regarding grey energy, which is an issue which is in no norms in Europe considered at the moment. And grey energy, I will come back to that later. What is meant with that? It's at least 13% of the life cycle of a building which is influenced by the construction method and the use of materials. Relation to local background, also what can be done, how can we construct it, and what is very important too, it's not only about material design and things like that. one thing is extremely important too, how the decision-making process is defined and how do you come to a certain goal. Because nowadays the things are getting more and more complicated because more authorities, more people are involved in the procedure, and you need to integrate them in a good way to be able to do it till the end. Okay, that's about efficient buildings. And now, how can we do buildings with low operating costs? What do we have to consider in that? How to reduce primary energy demand and CO2? Okay, at first, we have to look at the climate, and we have to design our building in accordance to the local circumstances. And we have to face this because what we do and what we try to do is develop our buildings always in relation to the climate factors on site first, and second also to the building optimization parts. Window wall ratio, are there operable windows? These are all factors which will influence the efficiency of the building. But this is, let's say, these are more technical factors you can see here. Here you can see the technical systems. They are only one small part, energy distribution and energy conservation. Technical systems are one part of this one. And what we think, and I will show you some ideas about that later, we don't think that the technical equipment of a building will solve the problem of reducing CO2 emission for the future. We don't think so. And also, once more, the comfort is one of the factors which will influence to achieve this goal. Now, I'm coming to the examples. Contribution to public space, that stands for the 200 years issue, for the figure of 200. Structure, which means our building needs to sustain at least for 100 years, structural-wise. The building envelope has an average lifetime of 50 years, the function of about 20 years, and the surfaces, let's mean that decoration and things like that, of about 10 years. I will illustrate that now with the next slides. And here you can see contribution to public space, 100 to 200 years. What does that mean? It means that if we are looking on the cities as they exist nowadays, they are influenced or they are defined through their infrastructure, roads, use of ground floor, the properties, and the volumes and the visual axis. That means the visual connections within the cities. And when we approach to a project, that's one of the first things we try to face. How can we implement our building in the best way to create not only these issues, but also a certain relation between the different parts which are already existing, so that we can get that value-added project in the end. But we have to consider these issues at first, and if we fail there, our project will be like a piece which is disturbing the order, and then it won't be accepted for a long time, and then it's not a long-lasting, not a sustainable project. Therefore, first thing, urban planning and let's say the urban design is the main task at the beginning. The second is to look about the structure, which means we need to find ways to organize the escape routes, the load-bearing systems like walls and beams. We need to look about protection, the technical potential, which means the flexibility of the structure, the vertical distribution, and ceiling means ceiling heights. There we can define the, how can I say, the ability of the building to bear different functions. If we do that in a structure in a good way, right from the start, and if we think it's not only there to be a residential house, but it can also be a commercial house, or it can be, let's say, kind of church, a religious place to be, then we think a little bit different than if it's only housing and where we say, okay, clear height 250 and it's done. We have to face that we should go a little bit further than that. Next thing is building envelope, 50 years, it's roof, windows, shading systems, and materials which we use outside. But also the building envelope is influenced by the technology which we use inside the building. Therefore, we have a method within our office, well, I come back to that later too, a method how we work on our projects right from the beginning. And one is that in combination with the facade and with the expression of the building, we are thinking how we use the technique which is inside. And because these two things are in a very strong relation to each other. Next thing, function, 20 years. Probably it's a little bit exaggerated, but our experience is that let's say, first, the life conceptions of the users, they are changing quite dramatically already nowadays. And that's changing all 5 years. And if we see that we are strongly influenced by a very vast communication between ourselves now, I think this is a very important fact. But also what we can see is that it's necessary that, that the functions could be changed, even if it's not absolutely something we have to see or if we want it, but that's a fact which happens. And in old buildings we investigated, that's learning from the past, is what we could see. When we look through their lifetime, at least they changed their function for 3 or 4 times. It was not only residential that was in, or it was residential in different forms. And we have to look at this, that we can work with this issue much more than it was done in the past. That means flexibility and a certain neutrality regarding the buildings. And surfaces, that's then the last part. It's decoration, walls, lighting, floors, atmosphere, everything which creates atmosphere within the building, and doors. These are things, probably they have a lifetime which is much longer. In best case, the lifetime of these materials, of these used materials, is longer. But very often this changes very quickly, because if the user changes, he also tries to make a new image of its own. So that's also a thing that, so all details and things like that is related to this issue. Now I'm coming to the first part. You remember probably when I said about long-lasting settlements, densifying. We think that long-lasting settlements are nowadays also quite often a question of best use of the building land we have and what we can do out of it. And so how we can create a better optimized use of square meter per capita. Second is the volume in relation to the built environment. That's what I said before. We need to think about that our project is not like an autistic object. And that's nowadays in architecture something we can see very often, and we don't like that. We think it should look nice, it needs to be a beautiful building, but that doesn't mean that it cries louder than the others. I think we need to set in dialogue. That's a very important thing in architecture. So another thing is public spaces and greenery. And if we talk about architecture and urban design, we are not first talking about our volume. The first thing we design is the public space. That's what we are interested in, because that's what makes life. The life is not only in the buildings, it's also outside the buildings. And only if we create place to make these relations happen, then it's a valuable project. And I think that's a very important thing too. So that means at the same time, these things are related. It means social and cultural acceptance. That means also for our projects, we need to look on the traditions, on the history of the site where we do our construction or our project, and not to implement the same language everywhere. That's not the way we should go on. That's what also is meant with local traditions. Then best use of traffic and infrastructure, because that's one of the big problems we have nowadays. We have everything or far too much related to cars. And we need to change this issue. We cannot go on like that. If that will be, let's say, bent over to other societies, like in India, like in Brazil, like in China, where it already happens in all these countries. If they use the same kind of mobility as we use it right now, that will be a big crash. It's something we cannot go on like that. So public transportation and infrastructure, which is already mostly there, not only in villages, also in towns, we have to use the infrastructures we already have in the best way. If we extend it everywhere, it's like a cancer. We have to look how we can limit the things and how we can use in the best way the things we already have. Now I'm coming to the first example. This one is, and it's now related to this aspect of density, more or less about density, but also in this project, and it's the project which is built on the former factory area of Renault in Paris. It's this building is called from the client Art Deco, even if we don't see in it any Art Deco, let's say, language. But he liked the project and he said, I want to give him the name Art Deco. The interesting thing about it is, first, it has a very high density. And the nice thing about this, what you can see here, is in former areas that was really all the factory of Renault. And now it's turned into a master plan from Patrick Chavannes into a residential area. Our project is located here, and we were invited to a competition, and we designed this a little bit strange shape, which is the result of different requirements from the master plan from Patrick Chavannes. And one of them is, first, he made this big boulevard. Second, he said he wants a clear possibility to go through. That means transparency, not only here, but also here, which means we have here big, how can I say, gates so that you can walk through. He wanted transparency and walkability within the quarter, and there were different other rules which also gave that we have a very strange shape within the building itself. But the important thing when I look on this plan is, first, it's part of the city. It's part of the city of Paris. And that's what we learned. We looked at Paris, and then we tried also to use the language, the material, and a little bit of the spirit, what we catched in Paris and what we said, it's extremely well accepted. Paris is one of the most visited cities in the world. And why? Because there is a certain relation from the building to the public space. And that's one, and not only that, it's also the material and the expression of the buildings. And if you look on the buildings, not every building is speaking in a different language. If you look on them, they are made in a homogeneous way, but they are done with the same material and with slight differences between the different buildings. And they have a common use of commercial areas on ground floor. And this is one of the things which was very interesting. So what was not proposed from us, it's also the client who understood that this is necessary to do so. We had here commercial areas on ground floor. This is a big restaurant or canteen, and also these areas are dedicated to commercial uses. So everything here is commercial use, and here is a kindergarten, and also this here is a commercial area. Everything above in this part is residential part. And we only made, let's say, the outline design of this building, and then the building was given to another architect. And the architect fully designed the building on his own responsibility. We only followed him. We were, let's say, the master planners for this block, but we had only dialogue with him about his project. And the influence was quite interesting because now I keep that later. I want to show you something else. What is interesting is the material of the building. We proposed natural stone, how can I say, a clear, bright natural stone, which is very familiar in Paris. It's like, it's their language. That's the vocabulary they use, and we use the same vocabulary. And then the project, which is a social housing, they had on the opposite side. The client of them said, okay, we cannot do anything cheap. I want not to be the bad guy within this master plan. And I say, okay, we take a little bit less thick natural stone, but we take also natural stone because he understood it's going about a relation, a dialogue between our project and their project. And that was the real big thing which I liked very much, that it was not only about formal issues. I will go back now, sorry, so that I can show the things before. This was the ground floor. What else we created is an interior court. And what you cannot see here, okay, this has to be left free for the kindergarten, but everything else here was planted or is planted with trees, and they form like a tree canopy, you know, like it's really a covered area out of trees. And if you look from the top now, you are looking into a little, how can I say, garden, like a little forest. And that's an idea we liked much. And then here you can see this transparency. The very big form we have is divided into 3 volumes. 3 volumes, why? Then we can have access from each of them into different big halls, and we can master them, or we can, how can I say, manage them as 3 independent units, or you can use them as one big unit. And that's what I am talking about when I say open buildings. At the same time, this is not only a dense project, because we made around 30,000 square meters of gross floor area on 4,500 square meters of ground floor. So it's quite dense already. But the thing is that we managed it, and here you can see on the upper floors, the form is getting slimmer, and at the same time there are no load-bearing areas here around. So you have a big kind of flexibility, and we showed to the clients also how he could implement in the future, if necessary, housing, residential units, flats. That's the interesting thing about the project. This is just about the shape of the building. It's not, let's say, only one big block, but it's separated. That's the entrance hall. Next one is yeah, here we can see that's from the back. On the top, here down is the restaurant, the terrace. Above there is another terrace, and this strange shape follows to the regulations which were given from the master plan from Patrick Chavan, because there were different distances to keep and things like that. In the background you can see the other project, the housing project. They also made, because that's something we said, the vertical window is the language of Paris. Everyone who works within our plot has to use this too. And that's what they did. Their proportion is a different one, but nevertheless they used also the vertical proportion, and now it's something, it's like a melody or a harmony and its variation. It's the same thinking behind. But it's very necessary to do so and to have a common understanding. A different form of densification is the project we did in Zurich. It's not in the direct center of the city, but very nearby the city center. The Metropolitans are 2 towers. You can see them here. And the density here is the same as you can find them here. And the project was about big problems with noise emissions, but a very fantastic view. And therefore we created this high-rise project. And the interesting thing once more is common area here. Let's say 2 entrance halls, 2 cores, 1 common area here as a public communication area. And it's not only that the residents of the project, they will come here, but also many others are participating in this common space. Then layout of a standard floor. As you can see, very simple organization, 1 core, 1 flat here with double orientation, 1 flat here, also double orientation, and another one, quite exciting one, which is going through like that, profiting from two orientations. And yeah, a quite efficient thing. And the interesting thing about this is too that how we can make it happen that they have interesting private outdoor spaces. And what we proposed is to create a very deep facade, and within this deep facade to make loggias, to integrate them, and not to just as an annex to have balconies or something like that, but really a zone which is running around, protecting the whole facade, but also the private exterior places. I think 16 levels of, let's say, standard floors, double high floor on the very top, where is how can I say, a common area, fitness and things like that. So that's for all the residents in the house. This is an area they can use together. And here on the lower floors there are services, entrance hall, and things like that. Nothing special. But a very expressive building, a very simple construction, but at the same time a very solid and very performant idea. You can see here sheltered in a background a little bit with panels, cladded facades, and everything here is made out of prefabricated concrete, but in a very perfect, Swiss way. Entrance hall. As I said, we have here also, it's a double high space, but other parts are already used also for flats. So we have this different use of this, and in this part on ground floor there are services which are used by the inhabitants of the tower. Here another one. Then the last one about the densifying. This is the project which is now under construction in Brussels. It's a competition we won 2 years ago. It's about the Belgium headquarter of the Banque Nationale de Paris, BNP. And it was a long discussion within the organization, should we do it or not? Because before there was here a huge bronze-cladded high-rise building. But the location is very interesting because I'm standing right in front of Victor Horta's Beaux-Arts building, which you can see here on the right side. This is the Galerie Ravestein, also very famous building. Down there is the Shell building, and on this side up there is the Royal Castle. So it's really in the center of the city. And what we tried within this project first to create a high density to be in profit of this extremely good public transportation. The main station is only a few steps away from here. You can even pass through the Galerie Ravestein, and it's 200 meters walk, and then you are already in the main station of Brussels. So that's a very interesting location. The location is this here, what you can see. This is the Rue Royale, this is the Palais Royal, and this is the Dutch Shell building, and here is the Victor Horta Beaux-Arts building. So a very prominent location, and also here there are classical fin de siècle architecture buildings in a tremendous good shape. So we were not allowed to touch them, and it's already part of the headquarters from the BNP, but they wanted a new building up here. And what we proposed is let's say, a very low structure. So we took away the whole high-rise building, even if it would have been possible to do another high-rise. But we said, no, we want to stay within the horizon of the city. So we don't want to get out of the landscape. And what we wanted also is to create interior courtyards which were not only for profit of the users of the building, for the bank itself, but on ground floor, which is fully equipped with commercial areas, that people can also benefit from the interior garden areas. This is one of the very important things within the project. And another one, you will see that later, is that we have a height difference from the Rue Royale to the main street we face with our project of 12 meters. So within our project, we have to master this height difference. The very interesting thing is this project is that we have 3 main cores, only 3 main cores and 3 escape routes. But beside that, we have a very open surface which can be used in an extremely flexible way. So this is also part of open building issue, and here you can see that we have also a large amount of exterior area in the upper floors. That's what I said before, the area when we have to step up these 3 floors, and this is the existing building from the bank, which is facing here the Rue Royale. And here you can see a little bit, no, that's the Galerie Ravestein, because Victor Hotter is hidden behind a little bit. But what is also the idea behind? Here you can see the Victor Hotter building right here in the corner. And here the other building is the one where the BNP is already has its part of its headquarters. And now what we tried is to make an architecture which is more abstract and which integrates in a very different way, not adding another, let's say, conventional classical facade with openings and closed parts, but a more homogeneous movement within the city, like an art piece, let's say, which we edit and which is also at the same time closed and transparent. And what you can see these green effects on the facade. That's not only Photoshop. You can see already the concrete pillars, which are prefabricated, each of them, and you can see they have a special form, and they are really done in that way. And it's concrete, which is then treated. It's a kind of green concrete inside, and we treat it in a way so that it's really getting green and white surface at the same time. And then you get this very special appearance of the building, as you can see it here. And here from the backside, view to the city, and where it stands here, there was like this, the former high-rise building. And here you can see that's the existing building at the moment, which is still part of the BNP Paribas. So next part, second one of 3, because then I will follow the part with resources. Open buildings. When we talk about open buildings, what does it mean? First, spatial organization of service opportunities. How can we implement different functions within the building itself? What kind of structural grid or floor heights do we implement so that we make it possible that you can integrate different needs and different as I called it before, life conceptions, so that office can be integrated, residential, commercial areas, and things, co-working areas, whatever you can imagine should be possible and not be, avoided. You need to force it, that things can be changed. Vertical organization of the technical installation, efforts, how to keep the efforts to make a different use within, you need to keep these efforts as low as possible. And you have to optimize the facade so that you can also make partitions wherever you want. And all these challenges are quite difficult to fulfill. I show you here one of the first projects we did in Amsterdam. This is the project which is called Solids, and the developer wanted a project because he was used to do projects which were a little bit fancy, which were good selling because they were a little bit à la mode, they were trendy and fancy, but he said, no, I have to stop with that. I have big problems with my residential projects because there are too much people moving in, moving out, fluctuation, and the acceptance is quite low. So now I want a project which is completely different. And he created this spelling of a building lasting 100 years. That was his idea, and he said, that's what I would like to have. And as in the surrounding are very little other projects at the moment, or it's something which is going to be built in the future, we try to make a very classical building, which has a very strong identity because there is a lack of language or context at that site, or it was at that time. And what we made is the first cornerstone of a bigger block, which will I show now. Here you can see what I showed right now is only this part here. But what we designed is the whole block, as in the Paris project too. And this was something which will happen then in the future. And what you can see already here, we designed common public spaces, arcades, as it's quite often raining in Amsterdam. So, and it's not really Amsterdam, I have also to say. It's a little bit off from Amsterdam. It's here, it's Eiberg. And Eiberg is outside. So it's not really in the center of the city. It's really a development area. And therefore, we also decided to make best use of the building land here, to make it possible that we don't have to spread all over, and that this problem which they have to face in the Netherlands more and more, that they don't have enough building land, how we can make best use of it. So we created open buildings. Here you can see it, one central core, and everything around is completely flexible. All constructed in the same way, leaving open all possibilities. At the same time, we wanted not to give it an expression of we don't care what happens, we make a modern language. No, we wanted to give him a certain touch of that the people have the feeling we know that they remember a little bit about things, about tradition. And that's something we wanted to be integrated into this project. And also in details, and everything was done in natural stone, and inside it's completely rough. It's left open because we don't know who will move in. And one of the things was not only that the client said, I will, or the developer said, I will do that as a building which is extremely solid. He also changed the way of marketing. And he put that building, when it was nearly finished, on the platform in internet, and I think within 2 days, more than 50% of the building was sold. It was really a great success. He was because the people, they saw it's not just a project as anyone else. It's looking in the same way as everything looks. It has a different approach, and I have the flexibility. And there are a lot of different uses. There are restaurants, there's a bank, there are residential areas, there are commercials even on the upper floors. It's a very, how can I say, interesting development it took. I don't know how it's nowadays. I would like to visit it and to see how it developed in the future. And another one is an older project we did in Tyrol, in Austria, where we had to make a social housing project that was in the end of the 90s. And what we proposed is a building, and that's the site. And we said we will make not one big building, we will make several separate buildings. That's the first thing. Second, we make them quite compact, high, compact also in their shape. We try to reduce the amount of necessity for elevators and stairs, etc. So only one staircase, but with a nice void in the center. And then we are able to manage, let's say, in the most stressed way, we can have 10 apartments per level, but only one stair, one elevator. And that's a very efficient way. And then we make a very simple shaped shell envelope all around, and then we have these things here as private areas. And the private areas are in order to the orientation are wider in some parts and less wide in the others. But you can step out everywhere. So the construction of this inner shell is everywhere the same. And we have here just these parts are bearing, and this one and this one. All the rest is open. And you can tear down all these walls, and you can really be very flexible in organize new and different apartments. The big effect of this was that the client was so satisfied after 3 or 4 years that he said we should now build the second part, the second stage of these, because we built it all of them, and then we added another five houses like this, because the acceptance from the residents was quite high, and there was practically no fluctuation. The people, they were used, and it's a huge developer, it's the Neue Heimat. They own more than, 30,000 flats in Austria, so they know what they are talking about, and they say they have the experience that this is one of the best projects they have at the moment in their portfolio. And then they decided, yes, we will go on with that. Another thing which was extremely important, the building was done within the budget of social housing, which is not that bad in Austria, I have to say. But it was only possible because we were very, modest with the materials, with the surfaces. It was compact and everything. And we had the possibility then to make a special kind of shutters, folding shutters, so that everyone can arrange the privacy and the view on his own behalf. So he has really the possibility to express himself or to choose complete closed privacy. And that's also something very important. The different buildings are sitting quite close to each other, but because of this, okay, now I have to pay attention about the time. The nice thing is that we were able to do not only very valuable facade, but also valuable interior. And that's more like a, let's say, 4-star or 5-star hotel entrance area than a social housing. And I think that's also something which we should learn. To treat social housing not as something where only low valuable materials are taken, but we have to invest in space, and on some parts we have also to invest in good materials, namely in the public ones. Then resource efficiency, I go through a little bit quickly. That's the ETH building in Zurich. We won the competition in 2001, and they wanted an iconic building within the competition with Harvard and, all Oxford. They wanted to show we are able to do the best sustainable building within all campuses all over the world. And this was the attempt to achieve it. Very shortly, it's located over here, so isolated, but in a campus it's very clear you can construct your own identity. There it's really object architecture in a way. And what we proposed, you can see here, different depth of facade in accordance to the sun inclination, and then here a fixed sun shading construction, which we all knew. We didn't invent it all on our own. We learned there are other architects, they thought a lot, like Corbusier, who did already Brise Soleil, but we have to work with that, and we have to develop it further. Another thing is that we have here completely neutral and flexible areas. Only here is the infrastructure integrated, and we have a very nice interior space with a big void and a central, let's say, this can be separated, but you can also walk through. If it's separated, then it's the auditorium. If it's not separated, you can straightly go through, and you can also use the upper floors over here to connect the two wings. That's what you can see here. Where you can walk over, and parts of them, like here, this one is this small void is this one. So it's a very spatially spoken, a very interesting interior design. And also the exterior design, which is done with massive travertine and with concrete slabs, so that we can get a very good sun protection for the whole building, as the problem in office building is not the heating, it's the cooling. So, and the most energy is needed for cooling. Here in this building, you need nearly no cooling because there is no exterior load, no sun is coming into the building. You can keep this out. This is one of the images about the interior organization, and this is how it looks like on this zone which is running through or around the building, and a little bit about the interior. Once more about the interior. Another one is the university in Luxembourg, which was inaugurated before last year, and this was the design from the competition. When did I? It was 2008. 2008. That was designed, and then it was a long history around. Here in the background, you can see the. That's for doing the Hochofen. It's you're making steel production. Steel production unit is behind, and what you can see here is the Dexia bank. We only made it very subtle, let's say, softly, so that it's not so much in the foreground. But our ambition was, because the program is just this, the whole program we did within the competition was this one. We added the volume because we said, in university, a public service should not be rated lower than a private bank. Never. We said we want to have at least the same height or even be higher. And that was our ambition. And we had to do that within the same budget. The budget was given. It was limited to 72 million euro. And we said, okay, we do everything here. We do also this, but only here core and shell. Not anything else. Not let's say, the finishings inside. And we were, at the end, inside of the costs. That's the nice thing about it. So where is it located? It's in Belval, it's in Luxembourg, and our project is this one. All these things you can see here around, all these things are part of university, which is slow by slow developed now, and which is already decided by competitions. But at the beginning there was nothing. There was only this old factory part here, which is now under conservation, and the Dexia Bank, which is this part here. Okay, here a little bit about organization. This is the, let's say, the building for with the auditories, with the seminar rooms, and that's like the infrastructure building for the whole university, which will follow. And here is the Mensa. And here you can see a little bit about the construction. And the nice thing is, first, inside here, only underneath these areas here, there's a little bit of technique for ventilation. Here inside, no ventilation at all, no mechanical ventilation. And that's a very big, interesting thing, because that was, to our knowledge, one of the first projects in Europe without mechanical ventilation for high-rise buildings. And what also you can see, and that's not just a joke, we make a second layer of facade, and this serves also for the protection, for the sun protection of the whole tower and the whole building. Otherwise, the loads from the sun would be far too big. Another one, and yeah, some special things about cantilevering parts and public areas, which are quite nice, relation to the existing parts of this old park. Inside, how it looks, and these are and then the conclusion of 22-26. That's now probably the more important thing. We have to face the fact that 31% of the overall CO2 emission is dedicated to buildings, 13% to gray energy. That means for the erection, transportation, building site, doing the building, and then for demolishing and removal of the building, 13%. The other 18% is for maintenance, heating, cooling, ventilation, and anything else which is necessary to keep the building up during its lifetime. 31% of the overall. So that means the challenge for us is this. which we have to face, and we don't know too much about at the moment because the norms don't refer to that. We're only treating this issue, but already to tackle the 18% is a big thing. And that means we need to keep the maintenance costs and the demand for energy. We need to keep that down. Otherwise, we will fail to reduce the amount of energy. Second thing, I will skip that, just to mention that the housing costs in our areas are rising much more, and let's say the housing costs are rising, and the average income is not following that. So the gap between my income and what I have to pay for housing is getting out like that. And now in Switzerland, nearly 50% of the salary has to be paid for if you have rental flats, and that's enormous. So that's another thing we have to tackle. Overall, energy demand. The ETH building I showed you before is going down to 93 kilowatts per square meters and year. So that's already not bad, but we think this needs to be improved much more, and this can be done. This is a building, how it runs at the moment according to standard. What does it mean? You can see here, that's the external temperature. Here in gray, you can see the comfort zone, which is between 22 and 26 degrees. That's the gray. And then you can see we have a problem. This is the interior temperature if you don't do anything inside a building. And then to come into this comfort zone, you need to heat in winter. You need this energy, and in summer you need energy to reduce the overload of energy which is inside. And that means you have heating and a large demand of heating and cooling energy. Now what is happening and what you are discussing at the moment is we are optimizing the buildings, which is great, because then you can really go down with your heating and cooling demand, because through better insulation of the shell, better technology, recovering energy which is used inside and so on, then you can reduce the amount. But still, you need systems for heating and cooling. That's the big thing, because you have to pay the installation, you have to make the investment, you have to use the surface for heating and ventilation units. And all these things cost enormous money. But not only this, if they recover energy, you need first electric energy to make it run. And where does it come from? It's not down from Earth. You need also infrastructure. You need to invest gray energy to produce these facilities which enable you to ventilate, to cool down the building. And all these things are not taken in consideration in an appropriate way. So the 2226 Lustenau building has its name because we try to solve this problem of maintenance and of energy demand. The project itself is located, it's in here. It's not a very interesting area. It's in the neighborhood of a village. It's more like a industrial area, I would say. And it's not really interesting, but the interesting thing about it is first the shape, and that the shape of the building and the thinking behind, and also the method which we used for this building is not only applicable in that under these circumstances. We can also do it in, I would not say anywhere, but in the most cities in Europe, within these climate conditions, it's possible to do such a building. First issue, it's an open building. We have this central core area, but around you can do anything you want. That's one thing. It's compact. Here you can see a little bit closer, and you can say, I close here, 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 then I have 4 independent units, or you can say, I leave it open, as the most at the moment do, and then I can walk through, and then I can have like this promenade architectural also in my little building, and everything is kept together. It's from the dimensions, it's about 24 by 24 meters in this kind, and 25 meters in height. Here you can see. And you can see we have here 5 standard, more or less standard levels, and a little bit a higher floor, 4.5 or 4.8 meters in the ground level, because we have a different understanding for the use of the ground level. We think the ground level should be dedicated to more public functions. Therefore, it's a little bit higher. But you can see also here the shape. It's quite clear and a very simple shape. What we also made as a proposal, and it's appreciated, we have also some interior connection, because this is not the escape route, but that's only the possibility to have connection in between. These about the plans. The plans are very simple. The things which is interesting, that this project works without ventilation, without cooling, and without heating systems. There is nothing of it inside. But the temperature inside the building is in winter and in summer, and really under really extreme conditions too. The temperature is always between 22 and 26 degrees. What you can see here is our building. Our building, if we don't do anything. This is the exterior temperature, which is measured over the year. And if you would do it, it would be a nice blue curve. But here it's always day and night. So there's a dramatical drop, and therefore it has this form. The second thing is the internal temperature of the empty building. If we don't do anything in the building, we measure it, and that's something you can do also with the simulations. That's how the building would behave if we don't do anything. There are windows inside, no one is inside, it's the empty building. And the range of variation within the year is only 8 degrees Celsius. That's the first very interesting thing. Then we said, what happens if we don't do any controlled system, but if the building is used? People are inside, there are computers, there are refrigerators, there are lighting, everything happens inside. What happens then in the building? And then the system is cooled down to 18 degrees and heated up to 28 degrees. That means we are here and here. We are above the range of 22 and 26 degrees. And the idea is that we should enter in it. And therefore it's written without any control system. Now, when we integrate our control system, then you can see what is happening all over the year. Now and that's the measured temperature within the building itself, under use with the control system and under these conditions. And I can assure you, because we have now experienced since 4 years, that this is the reality. And that's not something which is predicted, which specialists often have to do according to their norms and calculation modes. That's something we live in that building. We not only live on our own to be able to say it's perfect, it's rented out because there are other people's, other commercial enterprises are inside and they live within it. And we also integrated now on the very top floor some apartments to show, does it work also for apartments? And it works too. So what you can see, self-determination, you can open the windows and close them if you want. You can overrule the control system. Like in any hotel, you can interfere in a hotel. In some hotels, let's say, in the cheaper hotels, you're not able to open a window because there's mechanical ventilation. You're not allowed to touch anything. But if you have the opportunity to do so, that's a nice thing. Your humidity inside the building is very nice. Daylight quality is high, and natural fresh air is always given through the to the natural ventilation system we have. And the odor, the smelling of the building is also very good because we only used natural materials inside the building. The building has as insulation nothing. It has just brick. It's 70 centimeters of brick, and it's a certain kind of plaster inside and outside. And it makes a very good, performance regarding, not say that only the technical values, but also the acceptance within the building is quite high. That's the aspect from night. And what you else can see, it's a very simple cube, but at the same time we introduced in the cube a few things which makes the cube less, less boring. We made it a little bit fancy, you know, and it's anything can be done without touching the structure, without making big cantilevering or histories. It's a very classical building, and we learned a lot from the past, and therefore I added it to the title of today's lecture, because we work together with people from preservation of cultural heritages. They have knowledge about plasters, they have knowledge about natural stones, and we participated in discussions with them how we can introduce old technologies and knowledge into that building. But not only this, it's also about the percentage of openings in the outside, which is extremely important to understand how the building works. Here you can see, and what is one of the secrets? There are several things which interfere to the success of this project, but one is that we use the artificial daylighting, which is necessary in, let's say, in some parts of the year at a higher rate than in others. And there you can see that we have a good balance, and that we have energy we need for the artificial lighting is extremely low. If we compare it to other standard values we can see in the US or in the EU. And we use at first the amount of electric light only, or mainly, in the areas or in the parts where there is less daylight. And when it's less daylight, there is less exterior temperature. So it's necessary to make lighting, and then you can profit that it also gives energy inside the building. So that's one of the issues which helps us a lot to get a good quality. And here you can also see the demand of energy, electric energy consumption during January, February, March is higher, and also then starting October, November, December. But going down very strongly during the summer months, because then sun is there available, daylight is available for a very long time. And also here you can see that we have, in comparison to a standard electricity consumption, we have a very low rate in overall. These are the openings. Here you can see window closed. These are shutters which are closed, and then they are opened to provide good air quality. So the view is one thing, air quality is a second thing. You have to take care. This is the plaster of the outside and how the facade looks like, and it's treated not with color, nor outside nor inside. There's only one color which we had to put in, that's on the staircase, because it's an escape route, and there we were, obliged to use color to make it as bright as possible. But otherwise, in this building, there's no treatment of surfaces with lack color or anything. Everything is left in its original status, and also the treatment of the plaster. You can see really the work and the manufactured work behind, and which makes also a very interesting expression of the building. The energy consumption, and that's something now we didn't measure on our own. There is the German Institute of Norms. They made a publication, a book about this building in comparison to two other very famous buildings they have at the moment in Germany. And they said, we measure your building and then we will see what the performance is. And what you can see, that's the amount of energy which is needed now. And probably you remember, I showed you before the ETH, which was really at that status, one of the most performing buildings in Europe, with about 90 kilowatt per square meters. This is now going down to 45 kilowatt per square meter and year. So this is a drop down of 67%. And that's also something I want to express. If we're talking about carbon neutral architecture and things like that, we have to say we need a social perspective for our buildings, but also an economic perspective. And that's the target of our project, that we show that it's not necessarily expensive to do so, but it needs an approach where the conscience of all participants and also the developers, but also the architects, have to be new adjusted. We have to rethink a little bit our method of approaching to projects. This is how, and that's not a rendering, that's how it looks like. This is the public use on the ground floor. There is a little mensa where the people of the building, but also people from the neighborhood, they can go in, they can have a meal. There are some books, so you can sit here, and it's open to any other people who want to rent it for an evening, for their private wedding or whatever, that can be used. And at the same time, there's an art gallery also located there. Another thing is, then everyone would say, oh, but it will be complicated, it's different, you will have problems, and it will be more expensive. Not true, also not from us. It's done from the Vergleich-Baukostenindex, so these are people, we can't influence them. And they say, your building with the standards you have in, it's 25% cheaper than in comparison to any other. This is one of the connections between the different levels, which I mentioned before, this informal connection. This is the interior, how it looks like in one of the, when you enter from the central area. And this is one very important thing I want to say to you, the life cycle costs. Then, if we are talking about this, then we are not only looking about what it does costs in regarding construction, but only also regarding maintenance. And now you can look here, what happens. It's really a big difference, and that's what is interesting for us in the project. It offers new perspectives and new possibilities, but at the same time, and that's a big problem, because we are putting in question the technologies we are using right now. The most technologies, because what we are doing, we try to recover energy, we're doing anything else, but at the same time, we are using a lot of energy to implement these systems. And what we say is to reduce the systems and to invest in good management, in a good, let's say, operating program for the building, because that's also something you need to know when to open, when to close, how it may run, and there's a little bit know-how behind. So it's not that easy to make just 70 centimeters of brick and the thing is solved. It's a little bit more complicated, but it's a perspective, and we are now looking forward to do other projects in Berlin, in Zurich, and it's starting now, and the people have understood it works. At the first 2 years, they said, we don't believe that it will work. But now we can prove them it works, and we hope we are getting a step forward. And this is one of the tables. Dietmar designed them. It's without any glue, without a nail. It's only manufacturer art. And that's a thing, and it's massive wood, and it's not in a way cladded or, you know, that's real. And we like it. And with this final image, I would like to end, and I hope it was not too boring for you. Sorry. Okay.
Thank you for the presentation. Questions? Who wants to be the first? No questions? Okay. Good. Then no. I have a few questions then. Okay. You mentioned that the walls are 70 centimeters thick and that you used only bricks. And at the same time, you showed that the construction costs were 25% less than in an average building. Like for me as an architect, it sounds impossible, because if we want to build a new building from bricks, then the client says that it's too expensive. How is it possible that you use so huge amount of bricks and at the same time it's still 25% cheaper than the average building?
What I didn't show is what kind of bricks. It's if you would take traditional small bricks, it would be not feasible, because then you would have construct 2 layers, and that will be far too expensive already due to the manual process. But if you use bricks, large bricks of 35 centimeters, like there are, how can I say, products like Proton or things like that, and if you put them in 2 layers, then you get already a very thick facade. That's the first thing. Then you have to make up your mind how the bearing structure can be done, because these bricks are partly also quite performant in their insulation capacity, but others will be needed for bearing capacity. So you need to use different kind of bricks and to combine them. And then you have to pay attention about the joints and how you bring that together, that the joint is not going through, so that the transmission of energy is not getting a problem.
Okay, new question.
Thank you for a very thorough presentation. I have a question. It's definitely not a typical way to build a house. It's more consists a lot of innovation. How about the regulations? Is it in accordance to the local norms, regulations? How you deal with these issues?
No, it isn't. That's the first thing. Because, and I didn't stress that issue too much, the mode of calculation, that's something we learned in the different countries where we have offices in. Everywhere the calculation form is different. The method and everyone promises it's working perfectly. And the norms also predict perfect results. In the end, reality always proves us that it doesn't work. And if we talk with the people then and we say, we come with another approach, but we don't have the same calculation method as you have, because we have a specialist who is not a building physician. He's a physician, but a real one. And he calculates completely different. And he doesn't use the calculation forms and programs normal people use, because then you are coming always to the same results. And what we are doing, they would say, it never works. But that's the big thing. And then, if you ask me, how is it possible? It's only possible if you sit together with the people who have the force and the power to decide, and to talk to them and to make them understand what you are doing. And if they are going on in that way as they do, that they will never be successful. Also not in their authorities. So they understand very well that they need to quit the path they have at the moment, and then they have to think, how if we make only this exception? Is it really a problem or is it a chance? And they can see it as a chance. That's it.
Very good. It's very encouraging.
More questions? There is one.
Thank you. What's the trick with ventilation? You just open and close the windows, or is there some more tricks?
How can I say? First I have to say, yes, it's open and close the windows. Yes, that's the trick. But there's something behind, too. Okay, there's one thing, therefore I stressed the issue about height. It's good to have a little bit of height. Then you have more air. You need to ventilate less because the quality is better. In old houses, very often this was the case. If the flats are small, ceiling is low, you have to heat a little bit less, but you have open constantly your window to have comfortable CO2 inside. So the same thinking is here. We need to have a certain, or what is good is to have a good volume. And then we have to open and close the windows in a rhythm, and it should be measured. It's not up to anyone to open the window. It should be something to who, and that's our program which delivers this fact, is you need to understand when you have to open them, which is the rhythm and on which side, and also you have to think a little bit about how the windows are positioned. So there are a lot of little, I will not say secrets, but some screws, you have several screws which you have to handle at the same time. It's the same as I said before when I'm talking about long-lasting settlements. If we are focusing within this conference here on CO2, I say, nice thing, but it's only a part of 8, at least 8. And that's too small. We have to screw everywhere a little bit. And that's the same thing. If you put, let's say, a table here, it's doing like this, and then you have to calibrate it. And that's what happens also with any project. You cannot say, I have solved any problem with one idea. It's like decathlon. You have to face the fact architecture is not something where you can solve if you are good in one discipline. You have to consider 10 disciplines at least at the same time, and you have to work with them simultaneously. And that's the same thing with the ventilation. In the end, it's only that. But behind, there is much more. I'm sorry, it's a little bit, it's complexer than just to say, yeah. Is it okay as answer? Yeah, it's a program. There's a detection inside the building. In every room is measured humidity, CO2, temperature. And therefore, it is possible that this program knows if there are many people inside, I have to open more often the window, which is very simple. That's a very simple thing. But first you have to have the idea how I can come to this conclusion and how can I manage it, that it opens in accordance and that the people are not sitting there, oh, I'm cold, now it's open. And so there are a lot of questions also of comfort behind, and you have to consider also these questions. And therefore I say it's not that simple. But it's the program. We have to say the building itself, the hardware, is not anymore the most important thing. We need to implement knowledge, experience, comfort, and the users. In normal programs, the users are a factor which is not really taken in consideration in a good way. And if so, a lot of the buildings which have perfect thermal shell, best insulation, good mechanical ventilation, we did such buildings. I showed even some of them. But the result is not that the consumption of energy, of real energy, is really going down. It's better than comparable buildings, but still there's a big gap, and we need to reduce this gap. We need to tackle the energy issue in a much more, how can I say, offensive way as we do. And we cannot manage it only with technology. The technique will not solve the problem. The first real problem is in here. It's about our demand. And the demand of surface, for example, for housing units, is getting higher and higher. So in our areas, I have to say. I don't know in Estonia, that's something I don't know. But in our regions, we have now around 40 square meters per person. That's the average. 20 years ago, or 30, 40 years ago, we were down to 20. And this area, the quantity explosion, which is going all around the globe now, that is the problem. And we have to face the fact that it's in our brain. Do we need really anything everywhere suddenly? That's the big question. We have to really rethink a little bit our method of approaching to projects and to standards.
Okay, on one of the first slides you showed that resource efficiency is also very important for you, and also reuse and recycling of materials. What kind of materials are reused or recycled in this building?
Reused, no materials, but any of these materials used in this building can be recycled. The bricks, the plaster, the wood, and the steel. We have some steel in it, railings and things like that, and the concrete in the slab. We have this very thin slab. But otherwise, And okay, the glass, that's I discussed with with my colleague before. I said the glass, anyone says, oh, glass, no problem, recycling, no problem. It's not true. Inform you really what is possible to do with glass. If it's laminated glass, you cannot reuse it. You can reuse, if you make good-sized panels, you can reuse them, but you can never recycle them. And glass, window glasses, they are coated with things, and you cannot use them. And it's a very delicate thing to talk about. Glass is something which you can reuse. And the amount to make glass melted, the amount of energy you can imagine. It's really a lot that you have to. Therefore, I say the glass on this building you cannot recycle. That's one of the really bad things about it.
But is recycling building materials, is it common in Austria?
Recycling not yet. That's also something we have, I think, to do that, and that will come, that we have to reuse materials, and I think she will talk about that later in one of the projects probably. As she told me, they are doing now so in Norway in a project, and I also know projects in Switzerland where they start to reuse concrete, which is from a demolition area not far away. Then you can use it. Or if you have other materials. At the moment it limits to very exclusive projects where they say they like the use of aged products, wood and things like that. But it's not yet a real market, but it will come, I'm sure.
More questions? Nope. Well, thank you, Mr. Grassmann.